Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be taking a look at a possible alternative to Oracle's VirtualBox. This one is called Virt-Manager, and we're going to talk about that right after this. Yeah, so sometimes recently I felt like I've been pulling my teeth out trying to get Open VirtualBox to perform well. And I have been using Gnome Boxes more and more. So Gnome Boxes is kind of an easy way of getting introduced to KVM and QEMU. In some of the past videos that I've done, particularly with Clear Linux, I did it the hard way, which is that I set up a QEMU configuration file. But there are easier ways to do that, and Virt-Manager is one of the easier ways to set up a QEMU KVM. So that's what we're going to talk about, and we're going to see if it can be a suitable alternative to VirtualBox. Because one of the problems with Gnome Boxes is it's rather limited in the number of definitions or ways you can define the virtual machine, whereas Virt-Manager offers a lot more capabilities. And so as you'll see as we begin. So yeah, you know me, I always have to go back to the beginning. What was the pain and suffering that we went through that caused us to want virtual machines? So in the beginning, we used to install Unix and Linux alongside our favorite operating system. So back in those days, it would have been, for me, it would have been Windows NT and Unix, AT&T's System 5 for x86. So I had to put those up on the same machine, and I had to install a partition, and I had to steal some space away from Windows NT, and then install Unix on that particular another partition, and then basically would do the recycle reboot dance every time I wanted to run Unix or every time I wanted to run Windows. Unfortunately, there was no way to run both operating systems at the same time and just swap between them. Yeah, it works, but it isn't great. It's not much fun to be able to do that. Now, I noticed there's a lot of people still doing this today. They're dual booting between Windows and between Linux. There are some good reasons to do that because if you're installing and running native, you have direct access to the hardware. And so, yeah, if you're gaming and you're doing high performance work, yeah, there's some really good reasons to do that. So don't take this as saying don't do that. I'm not saying that at all. There are good reasons to dual boot. Some of the problems you're going to run into with it, though, is that an update can wipe, especially if you have both machines on a single drive. An update on one of them could wipe out the super block on the other machine. So. And the super block is what points at your next stage in the bootloader. So if Windows decides that it's going to update the super block, and it has on occasion done that more times than I would care to count, where all of a sudden your Linux partition isn't available anymore on the boot menu. Also, Linux is guilty of it too. Linux can go and write the super block as well, and occasionally updates do that as well. And so, yeah, it can blow away. It doesn't remove the partition for Windows. It just removes your ability to boot it. So, yeah, it just takes it off the menu. So, yeah, you can get it back. You just have to spend some time and rework the order of the bootloader on that system. It means you have to do something to overwrite the system track and get it back, the super block track back to where it was. The other problem that you have with it, now, you can easily, before I get off that topic, you can easily solve that. The easy way to solve that is to put Windows in its own hard drive and put Linux on its own hard drive on the same machine. And then the boot blocks won't ever be overwritten. You just use the BIOS, the system BIOS, to pick which one you want to boot from. Exchanging data, that's the big problem because you have to have some external means in order to take the data from Windows and be able to get it over to Linux. Now, that could be as simple as creating another partition that has a fat file system on it and mount that on Linux. And then every time you want to copy something over to Linux from Windows, you would just copy the file from the Windows directory over to the fat file system and then bring it up into Linux. That does mean, though, that you better be checking those files for viruses, because that's a good way to spread viruses into your Linux network. Even though they will not affect your Linux computer necessarily, they can if they have a Linux virus attached to them. But more likely, it would be a good way to spread it to other Windows users. So if you do that, you probably want to check the file before you move it, that it is free of viruses. And remember that Windows apps like the Doc and Excel and Word and Excel and PowerPoint have scripting languages in them, and so yeah, malware can be embedded inside of even a Word document. So anyway, back off of that. So yeah, you either had to have a disk, a USB stick, or a remote server in order to be able to exchange. So yeah, and painful. That was the pain part, is getting files exchanged back and forth and keeping them in sync. That's why the remote server option was often a more useful use case, because you could rsync between them. And there is there was, I don't know if there still is, there was a variant of rsync for Windows. But all that changed. When the Pentium chips came out, actually AMD was the first one to release virtualization on their chipsets. So you can thank AMD for really pushing forward things into the virtualization space. So that allows one operating system to run inside of another. Very simple. So that allows you to run one operating system inside of another. Sorry about that. Also, there's also another kind of hypervisor which basically takes control of the hardware entirely. It doesn't require a guest operating system, because it does have an operating system that does some very rudimentary functions. But that's not a topic for this particular video. We're going to spend it on desktop virtualization. So the performance is pretty close to a physical machine, but the thing you need to remember about virtualization is you are using the virtual devices. There is an abstraction layer between you and the physical hardware, and that is how virtual machines share resources. They create virtual layers, and then they do the work of talking to the physical hardware. So there is ways that you can pass devices through natively in virtualization, and QEMU and KVM both support that. But that's not a topic for today. We'll be here for hours if we do that. Level 1 has done a very good, they use KVM. So if you're interested in learning about that, go to Level 1 and go see how to do a pass-through on a device. So what are some of the things that virtual machines would be useful to do? So maybe you want to try out a new distribution. Maybe you have a new operating system version, a major one that's coming out, and you want to know what the impact is to your workflow. So you could install it on a virtual machine and kick the tires, play around with it before you commit to using it. The other thing is, maybe you have different setups that you need for your home environment. Maybe you want to keep your home life separate from your work life, and you don't want any way for those two systems to mix. Or maybe you just want to create a play environment. Maybe you set up a game environment where you have pass-through on your graphics cards and your audio, and maybe your USB ports for your keyboard and your mouse that you want to pass directly into your guest OS. Or maybe you have applications which don't run on the native OS that you prefer to use. So for example, I'm not picking on Linux, I'm just using this as an example. Maybe you need access to the Adobe product suite, and that only runs on Windows today. So if you need that, you could set up a virtual machine with Windows and install Adobe on it. It'll work. And then you can, every time you need to use the Adobe products, you can just launch the virtual machine. Or you can leave it up all the time and then just switch back and forth on your screen to whichever one you want to use. I'll show you more about that when we get into the demo. Or maybe you want to create your own cloud server, but you don't have the money to buy a physical box to be one, so you can install one in a virtual machine. It'll work. It'll work. Or maybe just need a place you want to test. You want to create a test environment. So where you have a specific set of controls in that virtual machine that you don't want disturbed by updates or any kind of thing that's going on around it. You're trying to control that test environment. So it's the same every time you use it. And that is important, particularly in commercial applications. So what does that for us natively besides VirtualBox? So there are 3 components I'm going to talk about today. I'm going to talk about the first 2 together because they really kind of need one another to work. So we have QEMU, KVM, and you'll probably notice that anytime those are mentioned, they're always mentioned together. So many distributions of Linux have native inbuilt support for virtualization extensions. That's part of the kernel. That kernel support is provided by KVM. That's the kernel-based virtual machine. And it is currently, at the time of this video, provided as a module inside of the Linux kernel that you can enable or disable as you please. And that just turns on the hardware layers for the Linux kernel to talk to the virtualization is implemented on the CPU, by the way. So that enables the Linux kernel to talk to your CPU and tell it, hey, I want to do this virtualization piece and I want to allocate this much memory and I want to reserve this much disk and all that stuff. QEMU is a fast, and fast is an acronym. It doesn't mean speed. It's an acronym. It's a fast processor emulator. So QEMU emulates hardware. And so it can do 2 types of emulation. The first is a full system emulation in which it emulates another PC. So it basically says, oh, I'm sitting on my PC at my desktop and I need another one. So QEMU will create a virtual one. And it can create as many of those as you have hardware to support. So notice that key word, as much as you have hardware to support. Make sure you leave some room, however, for your operating system. If you consume it all in a QEMU, you're probably not going to be happy with the performance of your machine because it does need to work occasionally in the system and user space of the native box. So yeah, that's the thing, is it supports creating and booting and terminating and doing all these things on a virtual machine on Linux. That's really the thing that from the background. So you can think of it in 3 tiers. KVM is the lowest level against your CPU. QEMU is allowing you to set up 1 or more virtual environments that share KVM. And so, yeah, the third piece is QEMU can do user mode emulation. User mode emulation allows QEMU to emulate entirely different types of chip hardware. So it can emulate, you could be on an x86 and you can run code that was written for ARM. Or you can run code that was written for RISC-V or CPUs, or you can even run native code that was written for IBM's S390 X series processors, which is a completely foreign CPU to anything that Linux understands or your x86 understands. So yeah, so that allows you to run different chip architectures under Linux. By the way, QEMU is what drives Wine. If you're familiar with Wine is not an emulator. No, it isn't, but QEMU is, and that's what allows it to run the Windows API. So cute, Wine, cute. And then third thing we have is LiveVirt. And that is the API layer that allows us to administer our virtual machines. It allows us to create a virtual machine, it allows us to run it, to tell it to run, and it also allows us to tell it to terminate. And of course, then it would pass off to QEMU, and QEMU would do the work behind the scenes. But that's all 3 of those components are necessary to doing virtual machines. So, and they're all open source. So LiveVirt's open source, QEMU is open source, and of course KVM is part of the kernel, and we all know that that's open source. What about installing this? What do I got to do to actually get this up with so I don't use VirtualBox? Well, I'm going to pick a couple of examples. Now, you can install this on Debian, you can install this on Arch, you can install this on probably every other operating system that has a modern kernel above 2.4, a modern kernel above 2.4. But yeah, you can. That'll still run on a lot of different kinds of hardware. On Ubuntu, it's simply a sudo apt install Virt-Manager, and that will bring in all the components that you need in order to run Virt-Manager with support for QEMU and KVM. On Fedora 31, I had to do a sudo DNF install at virtualization. Of course, that was done a long time ago. So virtlib has been on here, and if you have Gnome Boxes on your machine already, chances are you have most of it to be able to operate from. So if you're using a distribution that is not one of those, maybe you're on Linux Mint, maybe you're on MX, but go to your site and see how to install it. All of them, I guarantee all of them will support this. Now, for Ubuntu, I didn't have to do this step. I didn't have to go into etc libvirt and modify libvirt-d. It already did that. It set up the group. It even added my user ID to the group automatically when I installed the Virt-Manager. Fedora didn't, which is fine. Fedora doesn't always do things for you automatically. So if you want to check, there's a file in your etc directory under libvirt that's called libvirtd.conf. If you open it up in an editor, make sure that the comment is removed from the Unix sock group equal libvirt. If you don't do that, the only user on your machine that can run and install virtual machines is root. So that allows any user that's a member of the libvirt group to create and run virtual machines in the Virt-Manager. The second thing to look for is a Unix sock RO perms. Now, you'll need to uncomment that. It'll default to 0777, which means that it's basically anybody can read and write files into your virtual directory. So probably not a good idea. I changed mine to 077 to turn off world writable. I do allow the user and I do allow the group to do it though, because without that it probably wouldn't work. So this allows other users to run the virtual manager and connect to the libvirt-d service. So the next step is, of course, you'll have to add your user to the group if you're not already there. And you do that with the user mod ag libvirt and then put in the name of your user ID. If you have questions, there are wiki sites for Ubuntu and Fedora that go through this step by step, so you don't have to keep coming back to my video. I'll put the links below. I'm just explaining the steps to you here. The next thing you'll want to do is, once you've got all those things done, is attempt to start the libvirt-d server. And you use system control for that. You do a start libvirt, and then you do an enable libvirt. Enable, of course, allows it to restart the service on a reboot. So yeah, I had normally if I add a group to my user, all I have to do is log out, log back in again, and all is good. It's there. It didn't work with libvirt. It didn't work for Ubuntu, and it didn't work for Fedora. The only way I could get my user added to the libvirt group was to reboot the machine. I suspect there's something tying it up that's preventing it from occurring. I didn't read the logs. I don't waste time with logs. If I can just solve it with a reboot, fine. I'm not troubleshooting the software. So once you've done that, make sure you can do an ID from the command line and make sure you're in the libvirt group. If you are, you should be ready to launch the Virt-Manager, and your session should show connected to the QEMU KVM. So at this point, I'm going to go full screen. And let me get over here. There we go. And I just happen to have Virtual-Manager right here. Now, for a split second there, it said not connected right here, and then it said connected. If yours is saying not connected, make sure the libvirt-d is running on your system, and you can do that with a system control status libvirt, and make sure that you are inside the libvirt group. Those two things will prevent you from connecting to the port. Other than that, there is a troubleshooting guide on the there is a web page for Virtual-Manager, and they do have some support, but there's probably bloggers that'll probably have more information about it. So yeah, it's a pretty simple interface. Looks a little bit like VirtualBox without all the bells and whistles. This is how you create a virtual machine. That's what we're going to do. So I realize this is small. I don't think I can expand it any, but so I will tell you what it says. So this is the create a new virtual machine, step 1 of 5. And it's asking me, saying, choose how you want to install the operating system. So I can choose between install from a local media, that'd be ISO or a CD-ROM. I can install from the network. So if I have an HTTP, HTTPS, or an FTP server, I can install my operating system directly from there. I can use Pixie Boot, or I can import an existing disk image. Now that disk image has to be a QCOW, which is the native support. So you can't just take a VDI or an ESXi file and just bring it and drop it in without converting. So, and there are ways to do that. I'm not going to cover that. There are sites that talk about that, on how to convert from one virtual machine type to another. So if you're coming from VMware, you're coming from one of those kinds of support, or Hyper-V, yeah, you'll want to look at those sites on how to do the migration. But today I'm just going to install from an ISO file. So I hit the forward button. I'm on step 2 now, and it's telling me to choose the ISO or CD-ROM install media, and it is blank. There's nothing there. So I'll do a browse. And you'll notice that probably mine's a little different than yours. Yours probably only has default, and mine has downloads in it. Mine has downloads because I hit this plus button and added it. So otherwise, you're stuck in this folder right here, which is it's var lib/images. That is owned by root, and that allows you to pass out ISO files basically in a limited fashion to a number of users that might want to install a virtual machine of a certain type that you want to control. Because only root can add those ISO images in there. Well, because I have special privileges on my box, I have added one of my own personal directories to be able to do this. So yeah, so I'm not stuck waiting on somebody to give me root access to the drives. So, and this is native. You have to turn this off if you don't want somebody to be able to use their own ISO images, and there are good reasons for that too, in an enterprise especially. So for today, I'm just going to pick Alpine. This is the standard 3.1 that I installed the last time. I'm going to do 2 different ones. One is a text-only one, and then one is a GUI-based desktop install, just to show you that both of those work. Now down here, it's telling me to choose the operating system that you are installing, and it can't find it automatically, so I'll turn the automatic switch off, and I'll start typing Alpine. 3.8 is a little older than the one I'm currently doing, but it should be okay. And then I want some memory, and I'm going to put in 2 CPUs. So this is step 3, choose memory and CPU settings. I put in 1 gig of memory and 2 CPUs, and I'm going forward. The next piece is to enable storage for this virtual device. I'm not quite sure I guess if you were operating, like if you were putting Alpine in memory only, you wouldn't need virtual storage. But yeah, I'm not doing that. I need virtual storage. I'm going to do a sysinstall. So yeah, the last step is just to check and make sure that everything's here. There are some options that you can do for networking. You have host. You can put in if you have 2 physical devices, you can put those in, but you will need to create a Mac BT tap to do that. That is not done by default into your network configuration. So that's beyond what I want to talk about. So I'm staying with NAT for today. Just keep things simple. All right, so I hit forward, and now we are coming up. Now I'm going to scale my text a bit so that you can see it as well. And then I'll move it out from under my video, so hopefully that's a little easier for you to see. This shouldn't be unfamiliar to you. This is the same as what we did twice now. So this is now your 3rd time of seeing Alpine setup run if you've watched all the videos. Oh, let's do it the right way. Setup Alpine. Yeah, maybe I should go back and look at my own videos. What do you think? All right, so I'm not going to spend a lot of time explaining what I'm doing here. I'm just going to quickly rip through this because I've done this already. You can look at the videos. I'll put links to them. Okay, UTC, proxy, crony, yeah. Open shell, open SSH, I should say. And then my drive and sys. Yeah, you can install it. So it's going to go ahead and install all this stuff. If you've noticed that this is snappier than VirtualBox, congratulations. You've noticed what I have noticed. The VirtualBox is getting slower and slower. Don't know why that is, but it is painfully getting slower. Only the developers would know why that is. Okay, so I'm going to reboot. That should come up native because it will, as I said before, Alpine ignores the CD-ROM when it starts up on its normal boot. It doesn't ignore it. It just puts it lower in the priority. So I am installed. I'm not going to spend a whole lot of time with this, but I will show you one thing. So you notice I have an IP address here of 166. So if I create a user, oh, it's H. Always forget that. Okay, so, oh, whatever. So let's see. I should be able to, it's 160, covered it up now. 6. By the way, it's a Control-Alt to get out of the virtualization window, the console window. There we go. So that's one of the things you can do with QEMU, that it automatically sets up this path. Also, it does use Sprite, so if you want to use remote viewing of your virtual machines in a graphical environment, you can use the Sprite viewer to do that. So, but that again, not something I want to talk about today, but just to let you know that there's a lot more, there are a lot better ways of doing virtualization. So, done. So I'm going to do a power off and get this one out of here. Okay, so I'll go ahead and close up this window. We're done with that. And you'll notice that there's, well, you probably can't read it, but this is the Alpine Linux that I just created. And it has a graph here of the CPU usage. I can touch this and I can run it, delete it, clone it, you know, all the kinds of things that you can do. This allows me to show the virtual machine console, power on the machine, shut it down, all this stuff. So I want to create another one. Same thing, I'm going to install from local ISO. This time, however, I don't want Alpine. I'm going to go down here and install MX because that's the next thing I want to look at. Yeah, I know, I'm a little behind because that came out, what, October? Something like that. For the type, Debian 10 is probably close enough since MX isn't on the list. I'm going to give this one 4096. We'll stay with the 2 CPUs. Probably give this. Yeah, you'll notice that one of the nice things about the machine, the virtual manager, is it does remember, if you're in the same session, it does remember what your last settings were, so it'll use those. So if you have a consistent way, if creating your VMs, you can do that. I don't, so it doesn't help me a lot. So anyway, I want to change this to MX19, so I'll know what it is. And again, we're going to rescale the display so that you can read it along with me. Waiting for the background to come up. Usually there's a clock. I don't see it. So at this point, I could just go ahead and install it. There it is. So I could install this. I'm not, unless you, I'll tell you what, this video is getting a little long. My purpose of showing you this was to show you that QEMU and the Virtual Manager can work with GUIs as well. You can install Windows, you can install older OpenBSD if you want, or Linux as well. And that's basically what I wanted to show you today, was that that was possible. I'm going to save the review of MX for a future video. So, yeah, it's, you know, the Virtual Manager is a good way to get into it. Later on, if you want to go into faster ways of setting up and installing virtual machines. Oh, one thing I did not show you that I should show you. Let me put this back. So this light bulb right here, this has all of your settings for the virtual machine. And some of them you can change while it's running, just like under VirtualBox, and some of them you can't. So yeah, you can change memory, your boot load options here for which order it takes. This is your virtual disk. This is your NIC card, and you can use different drivers. You can emulate Intel if you want, or use the hypervisor default, whatever that is. There's your SPICE. There's the way that you can use you can set up a SPICE server to access GUI applications that are running in the VM. So you have a VM view outside of the console window, which is nice. Because you can then, if you allow remote access, you can do that. You can access it virtually, and there's a number of ways to do that. Your pass-through environments are down here, and again, I'm not going to go through all that, but yeah, that's all of the things you can set, and you can look at the overview for it. So I think I'm just gonna. I don't want to pause it. I want to shut it down. Ah, nice. It sent a shutdown message to the app. So, very well done, MX. Picked up on that. I'm not going to remove it. So, yeah, that's all I wanted to cover today, was just kind of give you a flavor for Virtual Manager, and maybe you'll try it on your own. Maybe you'll kick VirtualBox to the curb like I have. So I hope you enjoyed this video today. Please like and subscribe. And if you have a recommendation for another Virtual Manager, or maybe some tips and hints on this, great. I don't know everything, so please, please include any comments about it that you might have. Hope to see you again real soon, and bye for now.